The Homework Hotline is sponsored by Emily Griffith High School. Becca and I aren't the only ones here representing our school. We also have a student. Lily, tell the audience a little bit about yourself and how you help us out here.
Hi guys, I'm Lily, and I'm here to get your written questions from social media, email, and text over to Becca and Nate to help them get answered. At the top of each show, I will have a trivia question, and the trivia question can be on any subject, and if you're the first person to call in with the correct answer, you will win a prize. Today's trivia question will be on astronomy, and so you should call in your answer before the end of the show. And so today's trivia question is, what are the only two planets in the solar system that we can see from Earth orbiting in front of the sun? And we will get back with you about that at the end of the show.
Awesome, thank you, Lily. I'd like to also give you some of our other contact information because there are actually several ways that you can contact us here on Homework Hotline. The phone number is on the top of your screen. That's the best way to get a hold of us, and Nate gave you that number earlier. The other ways that you can get a hold of us are through social media, through Facebook and Twitter at EG Homework. You could text us if you want to at 970-680-3771, or you can even email us at homework@emilygriffith.edu. So all of those are ways that you can get a hold of us today and get homework help for all of those questions, those burning questions that you have that you're struggling with to figure out. So any way you please. Hope to hear from you guys soon. So let's jump over to Lily and get some of the answers some of the questions answered that we have kind of piled up on our social media board. We're going to answer some of those.
So the first question we have today is to solve for negative 81x plus 9 minus 81 equals 0. And it says to solve for y.
So,
Are you going to take that one?
9y. Oh, sorry. Yeah, I can definitely take that one. Let me actually write it down correctly, though. So plus 9y minus 81 equals 0. And we have to solve for y. Okay, awesome. So this is the equation that was given to us. It's up on my screen. And what it's telling us is that we have to solve for y. When we are told to solve for a variable, whether or not we can actually get an answer for it, like number-wise, it kind of depends on if there are other variables, but what it really means is that we need to isolate that variable. So when it says solve for y, we need to isolate y. And so what we do in order to isolate y is we're going to undo things in our equation, or basically think of the things that are being done to y and undo them to get it by itself. So as you can see over on the left side of the equation, we have this negative 81x, it's being added to y, and then this minus 81 is being subtracted from the y term. So you can start on either place. I'm going to start with the negative 81 or the minus 81, and to undo that, we'll do the opposite operation, meaning we'll add it. Now, when you do anything in math, it's always very balanced. Math is very balanced. And what we have to do is make sure our equations are actually equal on both sides. And so it's kind of like you can picture it as one of those old-fashioned scales where we have to make sure if I take something off of this side, that I also take something off of the other side so that the scale doesn't tip. So back to the equation, if I add 81 to one side, I'm also going to add it to the other side of my equation. Now, rewriting it on the left side of the equation, this 81 it's gone. The negative 81 and the positive, because they give you a 0. On the right side of the equation, we just have 81. On the left, what's left is this negative 81x and the 9y. So we're on our way to, I kind of think of this as a present and unwrapping it and undoing. We're on our way to doing that. Now we're going to take care of this negative 81x. In order to get rid of it or move it, we're going to have to do the opposite of negative 81x. So we'll add 81x to both sides. On the left side, it cancels, and we're just left with 9y. And then on the right side, we have 81 plus 81x. And the reason we write them as separate terms is because they are not like terms. They're not alike, and we can't put them together. The last step is we have this 9y. And in order to continue finishing, getting it by itself, it's 9 times y. To undo multiplication, we do division. So that means we're going to divide both sides of our equation by 9. And I use the fraction bar for division just because it's kind of shorter to write. So on the left side, the 9's cancel because 9 divided by 9 is just 1. And 1 times anything is just itself. So we're just left with y on the left side. And on the right side, we have to actually do our division. So we'll do 81 divided by 9, which is just 9. And then we'll do 81x divided by 9, which is just 9x. Now, I know we did not get a number solution for y, but we did isolate it. And so when we're solving for a variable, all we need to do is isolate it. And it's by itself. So solving for y, you get 9 plus 9x. So hopefully that helps, yeah, how to solve for a variable.
Yeah, I feel like these always look a little bit more complicated than they are, but the steps
do.
are really not any different than solving any other type of equation.
Absolutely, and it's all the same. If you have the correct structure in your head, like undoing
Yeah.
and combining like terms, they all kind of work the same way. Even though you have different looking equations, you kind of, if you follow that same general process, you can get through it. So
Right.
yeah,
I think we're going back to Lily, social media.
yeah.
Okay. So right here, he asks, the three side lengths of an isosceles triangle are m, n, and m. What equation can be used to find p, the perimeter of the triangle?
I can take that.
All right.
So the interesting thing is we said the perimeter of an isosceles triangle. So if you think, first of all, what an isosceles triangle is, it's just a triangle that has 2 side lengths that are the same. So they said the 3 side lengths are m, n, and m. So you notice 2 of those are the same because it's an isosceles. So if I look here, I have these 2 that are the same, m and m, and then 1 side length that's different. And we're looking for the perimeter. So again, just thinking about what the perimeter is, it's really the length that of these side segments that cover, let's see if I can do this real quick, or that close off this figure. So think of it like a boundary. So if you think about, like, if you have a backyard, and in your backyard you have a fence, the length of that fencing, what kind of closes off your yard, that's the perimeter. So if you wanted to calculate the perimeter of your fence, you would just add up all of those lengths. And we're really not doing anything different here. Where'd my pencil go? So perimeter, where is this thing? So the perimeter is just the length of all the sides. So in this case, all we're gonna do is add them up, m plus n. And depending on kind of what you're doing in class, if you wanted to simplify this, this is not the most simplified form. In order to simplify it, you would just combine your like terms, and you would get 2m plus n. And again, all we're really doing is looking for the length of all these sides combined, because we're trying to figure out how long the segments are that close off that boundary. Hopefully that helped.
Oh,
We're gonna go
sorry.
back to
I'm
one
sorry.
more social
All right.
media question.
Wow, not paying attention. Let's do one more social media question before we go to commercial.
So this one's an easy one. It just asks for 45% of what is 9%. Weirded worded question.
Do you want to do it?
45% of what is 9? Yeah, I can do this. So this is really, I think these questions can sometimes come off as a little confusing just because they're given in a format that you're not used to. You're not used to just saying 45% of what is something else. But if we think about how we would find that 9, we could say 45% of what is 9. Well, if I wanted to say, for example, 45% of 100 is something, I would just do, if you go to my screen, 100 times 45%, or 0.45, would be 45. And then if you just think about, well, in this case, we're asking something a little bit different. We're saying 45% of what is 9? Well, we've really kind of already figured out what you're used to figuring out, this kind of number here. That's going to be your 9. So we're saying 45% of what is 9, we can kind of just plug some different things into our equation here. So we have 45% of what, and we can say our what is always x. So in this case, we're solving the equation a little bit differently. So we're actually just going to divide by the 45%, divide by 45%, and I probably need a calculator for this. Thank you. And it's already calculated, so x is going to be 20. Let pen go. So what we're saying, again, we can double check this and we can say, okay, 45% of what is 9? Well, we said that what, or the x variable, is 20. So we can always double check this and say, okay, 20 times 45% should equal 9. In this case, 9 is 9, so that worked out.
Ta-da!
So hopefully that helped.
Seems easier than the is over us or is over of thing
Oh,
we
is
had to
that
do when
setting it
I
up
was
as
in
a-
middle school. That was so difficult.
Oh,
I
is
could
and
not.
of, yeah.
Yeah,
Is
that
and
was-
of, that wording is really difficult. In general, if you see of, you can think of that as multiply. Like if you're doing parts of something, fractions of something, or percents of something, so. All right, well, if you're just joining us, I'd like to give you our contact information one more time, just in case you missed it at the beginning. This is how you get your homework questions answered live. So our phone number is on the screen. That's the best way to contact us. That kind of stays on your screen all throughout the show. But you can also contact us via social media at EG Homework, or text us at 970-680-3771. Or you can even email us at homework@emilygriffith.edu. So all those ways, that's how to get in contact with us if you are just joining us now. So you can still get your questions answered for about another 45 minutes if you need to. All right, so we're going to go ahead and take a little break. What we're going to watch is what we call real world apps, and it's basically where we go and we interview people in the public and find out how they're using our subjects in their jobs and in their daily lives, and what did they need to know in order to be able to do their job. So I got to go to the Rockies Stadium and interview a baseball statistician. It was
Oh, wow.
It was really cool. It was very awesome. So check out that. Hi, I'm Becca Hendricks. I'm here at Coors Field where the Colorado Rockies play. I'm here for Real World Apps Math. Hi, I'm here with Doug Marino, and we're in the broadcast booth here at Coors Field. And I was going to ask him a little bit about how he uses math in his life every day. So tell me a little bit about yourself and about your job.
Well, my job is I'm the statistician for the Colorado Rockies television broadcasts for Root Sports. So primarily I sit up here in the booth next to the announcers. The announcers sit right here, and I sit next to them over here, and I pass them little notes that help the conversation along.
All
so
right.
if they're talking about a particular player, I've got some statistical information to pass along to them.
So you're the one that figures out basically kind of what they're able to say when it comes to, the Rockies this is their record, or this is this player's record, or...
Yep, these guys do a lot of research and they do a lot of homework beforehand. I'm there to kind of help them out and supplement because they're talking and they're doing a lot during the game. So if they want to know the answer to a question, I'm there to help provide that answer because they don't have the time to figure it out. They're busy talking on TV.
And so you're the numbers guy. You've got all the
Exactly,
numbers. How do you
exactly.
get the numbers?
Well, I spend a few hours before every game, before I come down, and I'll show you here. Here's what I've got for today's game.
On Post-its.
On little Post-it
I love
notes. It's
it.
a very high-tech business, but the very low-tech
Whatever
Post-it
works,
notes.
right?
Yep.
Right.
When different guys come up, I have different things to add to the conversation. Here, Justin Morneau is third in the National League in fielding percentage among first basemen. So when Justin makes a nice play, I'm going to hand that to the announcers, and they're going to talk about it.
Let's talk about this guy.
Yep.
Okay.
The Rockies are facing a left-handed pitcher tonight. They are batting .272 against left-handers. That leads the best mark in the National League.
So, a basic statistic, if you were just showing me some of the batting averages and
Yep.
some of these statistics that you came up with. Could you, for our viewers, do kind of an example calculation of something that
Sure,
you might...
sure. A batting average is pretty much the percentage of times you get on base safely by hitting the ball safely. You get a single, a double, a triple, or a home run. So let's say you've been up 100 times and you have 30 hits. You take 30 hits divided by 100 is 0.300.
So it's a ratio.
Your batting average is 300, which is, that's considered very good.
But where did you go to school? What kind of schooling did you do in order to learn to do what you do?
I went to the University of Dayton in Dayton, Ohio. I was
Okay.
a broadcasting major.
You intended on going into television.
I did. I've always been a baseball junkie my whole life, so I was always into statistics for baseball in particular. I used to play a little dice rolling game when I was a kid with different cards, and I would
Numbers,
keep
math?
statistics for every game. I would keep the box score, and I would total up everybody's batting average and their home runs and their RBIs after every imaginary game that I played. My mom used to yell at me to do my homework. Really, I was doing my homework. We just didn't know it at the time.
Just did it
Yeah.
a little different way.
Yeah.
So what would you say that you used from high school, from your classes in
I
job
use
now?
I use all of my math every day, all day.
From high school?
I sit. Yep, I do.
Middle
And
school?
middle school, high school. Some of them are very basic percentages and formulas. Some of them are, when you're learning fractions and percentages, that's what baseball numbers. A lot of them are.
Do you do data collection during the game, or do you have other people that do that for you during the game?
I have a database. It's called StatsPass. Is a company called Stats Inc. And they have a great database I can query all kinds of things from. So I use my computer skills for that as well. I also keep track during the game of a bunch of different things: the number of pitches, the pitchers thrown,
Right.
how each team is batting with runners in scoring position. So I collect information along the way, and then there's a variety of other places on the internet I can use as well,
Right.
as well as the printouts that I get before the games.
When you're collecting and analyzing this data, are you collecting it for all of baseball, specifically the Rockies, or specific players? How detailed are you getting?
Well, every time we have a series, a new team comes in, so I have to learn all about that team as well. So every game, I get ready for the Rockies and whoever they're playing. And we'll talk about season numbers, but then every time a guy comes up to bat, that number changes. So if he was batting .327 against left-handers, and he was 0 for 1 his first time up, he got out, then we have to recalculate that.
Right.
So we're up to date.
How long have you been a statistician?
This is my 21st year of covering Major League Baseball.
Wow.
I've been here in Colorado for 18 years. For the first 5 years I was here in Colorado, I did the visiting team. Like the Arizona Diamondbacks are in town now. When they came to town, they needed somebody, so they would hire me. But the last 13 years, I've been here doing the Rockies home broadcasts.
So what advice do you have for students that may want to eventually become a sports statistician or do something along the lines of work you do?
You have to pay attention to all your different classes. You don't know what you're going to use. You're probably going to wind up using a little of all of it, even if you think each statistician is just going to be math-oriented. I have to use all kinds of things.
So do you think that you have an unfair advantage in fantasy baseball leagues?
I usually finish in the top 2 or 3.
So if you want to have a view of the Rocky Stadium or similar, something like Doug Marino, then of course pay attention in school and pay attention to Homework Hotline. We're here to help you remember, and thank you again, Doug Marino, for answering our questions today about your job.
You got it. My pleasure.
Hi, welcome back to Homework Hotline. Hopefully you learned a little bit about possibly where math could be used in the real world. That's just one of the places, but that is definitely, if you're interested in math, a job that you could possibly go into.
I really like that example because in baseball, like so much is related to statistics. Like,
Statistics,
everything.
yes. Almost everything with sports, too. I mean, think about horse racing, just any stats whatsoever, and
Yeah.
how they track the performance of athletes and such. Yeah. All right. Oh, we have a caller. All right. So, hello.
Hi.
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 Thanks for calling Homework Hotline.
So I have a question.
Okay.
All right.
What is the slope of a line parallel to the line 9x plus 4y equals 7?
All right, I can take that one.
Okay.
So if you look at this line right now, it's actually written in, when you say 9x plus 4y equals 7, this is actually called standard form. It's a little bit more difficult to identify the slope in this form, so one of the things we want to do before we do anything is, you said you wanted to find the slope of a line parallel to this. Is that right?
Yes.
Okay. So what we need to do is find the slope of this line, first of all, so we can kind of compare the two. So are you familiar with slope-intercept form?
Yes.
Okay, so that is going to be in this form, y equals mx plus b. So if you notice for this right here, this is actually going back to what we talked about, one of our first social media questions, is you need to solve for y before you do anything else. And that's going to give you your slope-intercept form. So kind of what I do here is I just come to this equation again, that's in standard form, and I'm just going to solve for y. So to do that, I need to isolate, so I need to move this 9x over by subtracting it. And as Becca mentioned earlier, it's really important that in our equations, everything's balanced. We have to do the same thing over here. We're just going to kind of go step by step here. These cancel out because 9x minus 9x is 0, and I'm left with 4y equals. And you can write this as 7 minus 9x, like 7 minus 9x, but if you notice here in the slope-intercept form, it's important to just be consistent. So I'm actually going to write this in this order, negative 9x plus 7. And then going from there, we just need to, we're still solving for y, so this is being multiplied, so the inverse would be to divide. And now this is kind of the tricky part, because we're dividing this entire side by 4. The entire right side has to be divided by 4 also. So everything over here is divided by 4. Now this doesn't quite look like our slope-intercept form right now, because we have a little bit too much going on. So you need to keep in mind that when we say the entire right side is divided by 4, that means each term on the right side is divided by that 4. So I'm going to come over here, and all I'm going to do is break this up into 2 terms. So negative 9 over 4x, and then plus 7 over 4. Now this is going to be in slope-intercept form. If you remember from slope-intercept form, your slope is represented by this variable m. This is going to be your slope. So looking at our equation in slope-intercept form, we see that our slope is actually negative 9 over 4. That's my slope. So if you think about what that means, so if I were to graph this really quick, I would have something that looks like this, and then our slope is going down 9. Oh, I'm just going to approximate this because it's kind of a weird one. So it's going to look something like this. It's kind of hard to draw. This is basically what our line is going to look like. So when we talk about you're looking for the slope of a line that's parallel to this, well, any line that's parallel is going to have the exact same slope. So all I want to do then is say, like, any line, no matter where it is, for example, if I had another line that had a y-intercept here, would also need to have the same slope of negative 9 over 4. And that's going to be parallel. So a slope of a line parallel to this line is going to be really any line that's not the same that has a slope of negative 9 over 4. So hopefully that helps. Again, all we're doing, find the slope of that line, and a parallel line is going to have the exact same slope.
Thank you.
You're welcome. Thanks for calling.
Awesome. So it's great whenever you guys call, because then we can help you out a little bit more.
Yeah.
By making sure that when we interact with you that you're understanding what we're saying. So definitely call us in and we can help you with those questions. Let's go back to Lily and get some social media questions answered.
So she has a question, and it states, how many rectangles 2 inches by 3 inches can be cut from a piece of paper that is 9 inches by 1 foot?
All right, so I took what the information was on that question, and I kind of drew a visual of it on my computer screen. So what we're trying to do, it's a 9-inch by 1 foot, and 1 foot is just 12 inches. So I converted it to inches so that we're consistent along this. So what we want to find out is how many of these 3-inch, 2 by 3 inch, these little squares, or rectangles, sorry, that we can cut out of this piece of paper. So what I did is I decided to orient this. I did the 3 inches on the top because I know basically I'm going to be cutting, and I don't really have it's not straight lines, I'm sorry. And the reason I did the 3-inch on the top is because I know I could cut this 9-inch into 3-inch sections. I don't want to cut it into 2-inch sections because what will happen, I'll do 2, 2, 2, 2, 2. That'll give me up to 8, and then I wouldn't be able to cut another piece of paper. So the most efficient way to do this is by putting the 3 inches in line with the 9 inches, wherever you did it. And so the way we can think of that is with the 3 inches, we can do 3 of those, and that'll go into 9 inches. So I'm going to kind of sketch that out here. So 3 inches, 3 inches, 3 inches, like that. And then on the side, it's the 2 inches. And so then we want to think about, all right, we can go 3 across to fit into that 9 inches. We need to think about how many we can go down. And so if each one of these is 2 inches, to find out how many of those 2 can go into 12, we'll do division. And what ends up happening is we can fit 6 of them there. So I kind of drew those maybe a little bit big to start with, but we go 1, 2, 3, and these are not even, 4, 5, 6. So what ends up happening is we're going 3 across and 6 down. So 3 across, 6 down, 6 rows of 3 is the same thing as 6 times 3, which is just 18. So what that means is we'd be able to get 18 of these little pieces of paper cut out of this large piece of paper, so 18. A lot of times drawing a picture will help a lot with a problem like that, or drawing a diagram. It kind of helps you sort through maybe some of the logistics of like, well, what are they really asking, or how could I possibly figure this out? So drawing a picture definitely helps a lot whenever you have math problems to do.
All right, I think that figure really helps to kind of just visualize these word problems or just any math problems.
Yeah.
Drawing a diagram always helps a lot.
Otherwise, I can tell a lot of times, I'll just look at something and I'll be like, I have no idea how to do that.
Yeah.
And when you draw a picture, it's a lot easier to maybe visualize.
Just more clear as to kind of what's going on.
Yeah, exactly.
So as you may know, we're sponsored by Emily Griffith High School, so we're going to take a minute and hear a word from Emily Griffith Technical College and Emily Griffith High School.
Welcome to Nerd Necessities Network. You're probably thinking, what is Nerd Necessities Network? That's a good question. Nerd Necessities Network is a premier DPS TV show all about nerdy people, places, and things. Check us out on Facebook and YouTube and all the social networks. That's a wrap!
There's times when you wander and ponder all the labels you've received.
Believe me, I've got a few. Never mind from when, why, or how.
'Cause now, everything's different. I found the perfect place.
A space where the labels fade and I'm accepted and supported.
Check what the news reported. Emily Griffith helps all who wish to learn.
Turn towards your future while you finish the basics on your time.
Prime opportunity in this mature environment.
The only requirement is motivation and thirst for success.
Invest in your passions. There's no limit to how far you'll go.
And know that you'll have something in common with everyone here.
We all chose empowerment over standing still in fear.
So welcome back. There's definitely a lot to learn about Emily Griffith High School. If you haven't heard of us, look us up. If you are even slightly interested, you can get tours, you can get all kinds of information. So let us know because we've got a lot to offer there. So we're going to go to Lily, and Lily's going to tell us what's next.
So right now we're going to be talking about Facebook, and today's Facebook discussion is on growing plants in space, basically. And we're going to be talking about how astronauts have been growing vegetables on space stations for years, but have only been recently been able to eat them, I guess now. But we're not allowed to eat them till this past August. So yeah, it's pretty interesting. But
So this whole topic is actually really interesting. One of the things I thought of, I recently saw The Martian in theaters,
Haven't
and
seen that yet.
I will not spoil it, but the concept of the movie is Matt Damon gets stranded on Mars, and he basically has to find a way to survive. And his way of figuring out how to survive is he decided he wanted to grow food. So he successfully, in the story, in the movie, he successfully grew like potatoes on Mars. And he had an interesting method to it. So, and actually I looked it up too to see how accurate, how scientifically accurate it is. And the movie is actually pretty, they say, some of the sources I say it's actually pretty scientifically accurate. So maybe someday that'll even be possible.
Yeah, I was actually reading a bit also about how they kind of grow plants in space and some of the technology. And I know there's like aquaponic and hydroponic, but they use a different method called aeroponic. I guess that's like a different method for watering a plant. And it actually, instead of, pouring water in the soil, it's like a really fine mist. So they kind of load this nutrient-rich water-based solution, and it just sprays a really fine mist. And it's actually really cool because it's really efficient. It grows the plants like 3 times faster than how we typically do it more traditionally.
Wow.
But also it's an enclosed system, so nothing gets wasted if any nutrients aren't absorbed. It all gets kind of recirculated through.
And very important not to waste things when our
Yeah.
resources are limited.
As you learned watching The Martian.
Uh-huh. And actually, that kind of brings me to another point. So one of the biggest issues right now in space travel is growing food, and part of the reason is the price of eating. So currently, right now, we have to basically ship all of these prepared foods up into space to astronauts, and it costs, this is pretty ridiculous, it costs roughly about $10,000 a pound
Oh, wow.
to send food to the International Space Station.
Amazon hasn't gotten in on that yet, huh?
Yeah,
Apparently.
man, that's
Just get Prime
a
shipping.
market
they'll
that
send
has
it right up there.
not been tapped yet. Yeah, Amazon Prime
$80
it.
a year.
Exactly.
Awesome.
Flat rate. But $10,000 a pound to ship any kind of food. And right now it's really all prepared food. So they get plenty of food. It's just packaged and prepared foods. But it's also really important to get fresh food. It has fresh food. I mean, think about it. If you just ate canned food all day, every day for weeks and months on end or years on end, you'd probably be lacking some nutrients. We can maybe synthesize some of them, but lacking nutrients. But then also eating fresh food is really good for us. It connects us to the earth. It taking care of plants and taking care of things like that helps with stress reduction, mood improvement. It helps with depression. And think about if you were stuck in a metal area for months at a time and not able to get out and travel, how possibly depressed you might be or how that might affect you emotionally. So by being able to grow plants and prepare your own food really would help a lot with just your psyche.
Maybe just give you something to do every day.
Yeah, it gives you something to do too, for sure. And a lot of health benefits too. So kind of important for us to be able to figure this out.
I find it weird that before they are able to eat the food, they have to clean it with citric acid before they eat it, and also sanitizing wipes. Which
Why
I
is
found
that?
very weird. I don't really, microbes, that's a main factor, but I don't know, it just seems eating something with citric acid on it, I don't know, it just doesn't seem safe to me, but
Or sanitary wipes.
it might
on there,
evaporate in a way.
Safer than some of the
I guess
bad
flavor,
germs,
flavor
right?
is not the goal. So.
Yeah.
True. We just need to be safe.
Yeah.
So let's sanitize our food first.
But yes, the article is back up now, so I didn't have it up before I started this conversation, so now it's up. So if you want, you can actually go on the Facebook and actually check it out.
So if this is a topic that's interesting to you, you can definitely learn a lot more based on our Facebook site.
Oh, it sounds like we have another caller.
Oh, good. Yay, caller. All right, hello?
Hi.
Hi, thanks for calling Homework Hotline.
Yes, I need a lot of help with this. I got this freaking gas question, and I don't know what to even do to approach this.
Okay.
All right, let's hear it.
What's the question?
All right. A car averages 27 miles per gallon. If gas costs $4.04 per gallon, how much would gas cost if you traveled 27 miles?
If we traveled how many miles?
2,727.
Okay. Ooh, I like that. I
And this
like this
question-
question.
Might have been written a while ago when gas prices were over $4.
Yeah, or it could happen again. I don't know.
I think it probably will.
Good hypothetical situation. I like these kind of questions just because being the math nerd that I am, when I'm in my car and I'm making a long road trip, I start thinking of these things. I'm like, I wonder how much it's going to cost me.
I've usually calculated it well in advance of the trip.
Oh, so you're prepared. I'm
I
just
am.
more on the fly, but I'm definitely math nerdy about it. Okay, so are you watching the show by any chance?
Yeah.
Okay, so I'm going to throw some things up on my screen, and what we're going to be doing right now is called unit analysis, which means we're going to use the units of our equation, like miles and gallon and whatnot, to help us get to what we want. So we know that it's 27 miles per 1 gallon. And we also know, and so we're going to multiply these as kind of like a thing that we do. So we know that it's going to be $4.04 per gallon. So I'm going to set up my gallons on top of this and the dollars on the bottom. So what this would basically do is, with unit analysis, is it's going to the gallons and the gallons, the units cancel out. None of the numbers cancel, but the units do. So think about when you have a fraction, you have 4 over 4, 5 over 5, anything over itself just equals 1. And if we are multiplying anything by 1, it doesn't change anything. So that means we can cross out the gallons and the gallons, because it's gallons over gallons. And then what that tells us, or that information tells us, is that we can do 27 miles for $4.04. If we actually do that division, what's going to happen is it'll tell us, and actually I'm going to reverse it and switch it. The reason I'm going to switch it is because I want to find the unit rate for miles. So how much basically it's costing me for 1 mile. So I'm going to switch it, and I'm going to call it $4.04 for every 27 miles. And then I'm going to actually divide that to find the unit rate, so what it would take me for 1 mile. So I'm going to do $4.04, so $4.04 divided by 27 miles. So what that tells me is that it's going to cost about, and I'm rounding, 14.96 cents. And so actually I'm going to go ahead and round that up to 15 cents. So we'll call it 15 cents per mile. So are you following me so far?
Yeah.
Does that make sense so far? Any questions on that?
No. Just try to follow all the miles, all the gallons. I'm following for the most part.
Okay. One of the things that's really helpful when you do these is actually writing the units out, like miles, gallons, dollars, because it kind of helps you get things straight of, where to set them up and where to put them and that kind of thing. So then, since we know it costs 15 cents for 1 mile, you said that we're going to be traveling 2,727 miles. Is that right?
Let me check real quick. Yes, that's it.
Okay, so 15 cents is for 1 mile, so what we can do is take that 15 cents and multiply it by the 2,727 miles, and that'll then tell us how much it'll cost for that whole trip. So we'll do the 15 cents times 27.27, and we end up getting $408.04.
Dang!
I know. So
Gas is
actually,
not
but
cheap.
that's a pretty far trip. Think about it. You're going to 2,700 miles. That's
It's about the
almost the whole
entire
way
country.
across the
It's
U.S.
pretty much,
About,
yeah.
I would say, about, if I had to estimate. So that's expensive, but it's a pretty long trip.
Yeah, I mean, you made it from the West Coast to the East Coast, maybe
Yeah.
$400.
Yeah, not too
Or I
bad.
could just take a bunch of short trips to the local Pizza Hut. There's like 20 I could do 20 dinners there.
That's so true. You get a lot out of that.
That's a lot of pizza.
For $400. That's a lot of pizza, though. So did that help? Did you get the help you needed?
I definitely wrote down everything important.
All right.
Maybe.
Good.
But
I hope
thank you
so.
anyway.
Well, if you need any more help, you can always call back. There's no problem in doing that. So just put our number on speed dial for any time you need us.
I mean, I got like 3 more tests over here.
As long as it's between
All
4:30
right.
and 5:30 on
Perfect.
Tuesday and
Yeah, it
Wednesday.
just has to be on a Tuesday or a Wednesday, or save them in social media them.
Right.
But awesome. Thank you so much for calling. We appreciate your questions and glad we can help.
I'm glad you could too.
All right, take care, and maybe we'll hear from you soon.
Bye.
Bye.
I think we're going to toss it back to Lily for another social media question.
All right, great.
Guys, so we have a question that says, I don't understand how to solve this problem. How do you find the greatest common
Can we get this
factor of 27 and 90?
Okay, I think I can take this one. So greatest common factor of 27 and 90. This often I've noticed gets mixed up with least common denominator.
Or least common multiple.
Or least common multiple.
Oh, yeah, all the time.
One good thing about just terminology and math in general is you can break these up and just think about what this means,
Awesome.
greatest common factor.
I'm glad you're doing that.
Yeah, so I'm going to write down on my screen, I'm just going to write down those words, greatest common factor. Now, individually, you probably know what all of these words mean, but let's think about what they mean combined. So when we're talking about factors, we're really just talking about 2 numbers multiplied together that are going to give us a certain product. So one way that we can do this is we can look at, okay, what are the factors of 27? So I'm just going to go through and write down all the factors of 27. So we have 1, 3, 9, and 27. These are all factors of 27. I'm going to do the same thing for 90. What are all the factors of 90? So I'm just going to write down 1. It's an even number, so 2, 3, 5. What are some other ones? 18, 30. Am I missing any?
3, 4, 5.
I think that's about it.
7, 8. What about 9?
Oh, I forgot 9 and 10.
9 and
okay.
10.
I'll just squeeze
Ooh,
those in
that
there.
would make you get the problem wrong. if
Yeah,
you
it would
forgot that
actually.
one. Ooh,
So,
can I show really quick?
Yeah.
I've got a method to help with not forgetting any
Oh,
of the
okay,
factors.
yeah, that'd be great.
Okay, so go really quick to my computer. I was also working something else out that I was going to explain later. But here's kind of a method. If you look on the left hand of the screen, it's a method that I use to make sure you don't forget factors. Because that's one of the hardest part with the factors is leaving some of them out. Like, did I miss anything? Do I have them all?
Especially with these bigger numbers like 90, there's so many.
So what I do is this, I kind of make this little T-chart, and I'll start on the left-hand side, and I'll start with the number 1, because I know that's always going to go into that number 1 and itself. Then I go and I check the number 2, and I will check, okay, 90, yes, it's divisible by 2 because it's even, so 2 times 45. Then I'll check the number 3, 3 times 30. Then I'll check the number 4. Oh, 4 doesn't go into 90. Then I'll check the number 5, and we said it was 5 times, what was it, 18?
18, right.
Okay, 5 times 18, and then I'm going to continue, and 5, 6 doesn't work, 7 doesn't work. Oh wait, 6 does work. 6 works, hang on. 6 times what? 15,
that doesn't work.
right?
Oh, 6 times 15, yeah.
Yeah,
You're
oh,
right.
we forgot that one too.
Oh.
Ooh, good thing. Okay, 7 doesn't work, 8 doesn't work, 9 works, 9 times 10, and then here's where the trick is. This is kind of what I wanted to show you. So 9 doesn't work, the next one we would test is 10. However, we already have 10 on the other side. So that means we've already listed as a factor. We've kind of met in the middle there with the numbers, like we're overlapping now. So as soon as you're overlapping, you now know that you have all of the factors. So it's kind of like a neat little trick, and then you can just list them. 1, 2, 3, 5, 6, 9, 10, 15, 18, 30, 45, 90. So just write a list of them. This is kind of a neat little method to just help make sure that you don't forget any of the factors.
Yeah, I think it's really helpful to have just a methodology for doing that, because otherwise there's so many factors of 90.
I mean, that was the thing I always hated about greatest common factor, is I never knew if I was missing anything. I was like, well, I think it's 5, but...
Yeah, so I went ahead and rewrote all those factors that I kind of missed early on. So again, we have all the factors, right? Because we're saying greatest common factor. Well, these are all the factors of 27 in yellow, and these are all the factors of 90. So the other thing we're looking for is, so that's what a factor is. These are all factors. Again, just thinking about each word individually, what does common mean? And it just means things that are shared, they're the same, right? So
right, like if you and I had something in common, we'd have something that's the same about us.
Exactly. So like we're both math teachers, so that's something we have in common. So what are some common factors? Well, if I look over here, 1 is a factor of both. So this is a common factor. 3 is a factor of both, so these are common factors as well. But we're actually specifically looking for the greatest common factor. So what is the biggest number that's a factor of both 27 and 90? If we had these all listed out, we could just kind of look and say, well, 1 and 3 are both factors, but 9 is also common for both of these, and it's the greatest number that's a factor of both. So that would be the greatest common factor, would be 9. So hopefully that clears it up. And again, like least common multiple, least common denominator, these are things that always get mixed up, but just think about what each word of one of these words means individually if you ever get stuck on that.
Absolutely. And I'm actually going to show you another method right now. I don't love this method, but I'm going to show it to you because maybe you will like this one better. And that's also one of the great things about math, is that there's not always just one way to do things. We can have multiple ways. So another way to find the greatest common factor is by doing what's called, and I'll write this out so you know, it's called prime factorization, otherwise known as factor trees. So what you can do is take each of your numbers and find all of the prime factors of that number, break it down with the factor tree, and then list the prime factorization of each of those numbers. So when we take 27 and we break it down to all of its smallest numbers, all of the prime numbers, we get 3 times 3 times 3. When I break down 90, you get 3 times 3 times 2 times 5. Now, greatest common factor, what you can do is you circle everything in those lists that are the same. So 27 and 90, 3 is the same, 3 is the same, and then we also have another 3 that's the same. I can't circle the third 3 because there's not a third 3 on 90, but there are 2 3s on each of them. And then what you can see is 3 times 3, that the 3 times 3, is our greatest common factor, which is 9. So that's another way to do it. I don't love this way just because it's not easy to remember. You can do least common multiple very similarly, but it's not easy to remember the difference between the two. So the way that Nate showed you, where he broke down the words, that, to me, that's the best way to do it, but there's also this other method that you could use as well if you wanted to.
Yeah, I do like that there's just a lot of different ways to do everything, so you can kind of pick and choose. I know some students like doing factor trees.
Yeah, I always
So,
like factor trees, so.
Yeah, if you prefer that and it works a little bit better for you kind of visually, then definitely go ahead.
Absolutely. So you basically get to choose your way. All right, so we would like to make sure that you are aware of what our trivia question is. You get a prize if you get to answer the trivia question correctly by the end of the show. The trivia question, just to remind you, is what are the only 2 planets in the solar system that we can see from Earth orbiting in front of the sun? So the 2 planets that we can see from Earth. So give us a call if you have an answer to that. We do have prizes.
Is Pluto still a planet?
Sorry?
I don't know. Is Pluto still a planet? It keeps on getting its status taken away.
I consider it a planet.
Yeah.
Just because
You know-
it's dwarf, you don't consider dwarf people
Not
humans.
people.
So that's just rude. But it's considered
Okay.
not a planet.
Well, I guess technically it's not a planet.
That's
so-
really hard when you learn so young that it's a
It
planet.
is.
It's really hard.
Yeah.
I learned in 4th grade that Pluto was
And you
a
just
planet.
don't
and it's
wanna
just
let it
hard
go.
To take that out
I
of my
I
mind.
thought Pluto was the cutest planet because it was the smallest.
It
And
is.
It was cute and blue. I was like,
So
"Aw."
cute. All right. So let's go ahead and take another social media question from Lily.
Okay, so we were talking about imaginary numbers, what we learned in class yesterday.
That's true.
And it states negative 5i times 6i equals negative 30i squared equals 30.
Okay. So this is an example problem, and I can explain this. And actually, probably at this point, Lily could explain it too, because this is what we did in class yesterday and today. And Lily's in my math class. So this is something I did actually today. So I is this what's called an imaginary number. And if you haven't gotten to this yet in math, I don't want to totally blow your mind, but there are numbers that are not real numbers, they're imaginary. And the reason we have imaginary numbers is because it helps us deal with what's negative square roots. So let's say you had something like the square root of negative 4. It doesn't exist because square root means something times itself equals this number. And there's no way that we can do a negative number times a negative number is not going to equal a negative number. And a positive number times a positive number also not going to equal a negative number. So it helps us deal with negative square roots. Either way, this I character here, this I, it looks like a variable, but what it stands for, or what it represents, is the square root of negative 1. Thus, in turn, if we had something like I squared, so that means we're squaring, we're taking negative square root of negative 1 times the square root of negative 1, would just give us negative 1. So I squared is actually a real number, whereas I is an imaginary number, which, sorry again to blow your mind if this is not where you are yet in math. However, this idea can help us simplify something like negative 5i times 6i, so imaginary numbers. I works just like a variable when it comes to our rules of simplifying. So if I had something like negative 5x times 6x, what I would do is I'd take my coefficients, negative 5 and 6, multiply them together, negative 30, and x times x gives us x squared. So, same idea with this one. Now, we're not done simplifying at negative 30i squared. What we need to make sure that we do is if we have anything real, we want to replace it with what that is. So I squared, as I just mentioned, is the same thing as negative 1. And so we could replace this I squared with negative 1 and then multiply negative 30 times negative 1, which is what gives us 30. So that is why something like negative 5i times 6i can actually equal a real number, like 30.
All right, it looks like we're going to go back to Lily to get the answer to that trivia question.
Okay, so the trivia question again today was, what are the only two planets in the solar system that we can see from Earth orbiting in front of the sun? And the answer to that was Mars and Venus. Come on, guys, you should have known this.
Yeah, that's easy. I mean, you can see them without even a
Yeah.
telescope. You don't even need a telescope to see them if you have a pretty clear sky at night.
Just that big red dot. Just keep on the lookout. You'll see it.
It's red. You're
Yeah.
right. Mars is red. So, and it is pretty bright in the sky too
Yeah,
compared
it
to the
is.
stars. So, pretty easy to actually see. But one thing though that I did learn is that so with the naked eye, still without a telescope, you can actually perceive and see up to about 3,000 stars, which seems like a lot, but compared to how many stars we have in the galaxy, we actually have a lot of stars in the galaxy.
I actually thought it was more than 3,000 that you could see.
You thought it was more? Well,
Yeah,
it
I
probably
did.
depends on where you are.
That's
on-
true. We have a
on
lot of
Earth.
clouds and
Yeah, where you are,
light
what the
pollution.
visibility
Right.
is, if you have light pollution, if you're in the city or if you're in the country.
Yeah, it's kind of the same with an eclipse. You have to be in a certain place, unless it's lunar, I guess. I don't really know if you have to be, but in a solar, you have to be in a certain place on Earth to be able to see it visibly.
Mm-hmm.
So,
Yeah, and it definitely changes. So depending on where you are on Earth, the different constellations that you're even able to see
Oh,
are
right, because
different.
they could be in a
So-
different place orientation-wise.
Absolutely, absolutely. So, yeah, and the hemispheres also make a difference. So northern hemisphere, southern hemisphere, and so on makes a difference. So, did you learn anything about?
I did actually, and it's kind of hard to pronounce, but I learned that one of the first astronomy mechanisms called the Antikythera mechanism was actually discovered, that was developed like several hundred years ago, and it's kind of interesting. It was discovered by or it was created by the Greeks. But it's kind of interesting because you wouldn't think that long ago that people were so kind of, what's the word?
Educated about?
Yeah, educated about and like
Astronomy.
excited about learning about kind of what all those stars are out there.
See, I feel like that's obvious. Like in the sense that if I were living in that time and I didn't have the information I did and I looked up at the night sky and saw the stars, I would be like,
questions.
what in the world are those? I just feel like I would really absolutely want to know what the heck that is.
yeah,
'cause
it's
they're
kind
so
of like
cool.
what Homer does in the Odyssey. He explains a lot of like the constellation he sees, and it's pretty cool. He talks about the Orion and stuff.
Very interesting.
Yeah.
Well, thank you guys for joining us again on another wonderful episode of Homework Hotline. We will be back tomorrow, Wednesday, from 4:30 to 5:30. So if you didn't get your questions answered today, maybe tomorrow you can get them answered. So thank you again for joining us, and have a great night.